And as I mentioned before, this will be recorded, so you will have access to the lecture to view at your leisure. All right, so this section is talking about solving equations, first degree equations. All right, so an equation is a statement that two algebraic expressions are equal. So an example of that is x plus 5 equal to 7, just a simple example. X plus 5 is equal to 7. A solution is a value that will make an equation true. So whenever you're trying to solve an equation, you should be asking, when is this true? Or in other words, when is x plus 5 equal to 7? And the answer is when x is equal to 2. Mm-hmm. And also, if you guys need me to re-explain anything, or if you need me to slow down or scroll back up, you're gonna have to say it through your mic because I don't have access to the chat right now. While I'm looking, I don't see the chat right now. So.
Could you scroll back up real quick?
Mm-hmm.
Thank you.
All right. I'm good. Am I good? Uh, all right. So we will be solving by using what I call opposite operations. The operations that undo what the other one does. So addition and subtraction will be considered opposite operations. Multiplication and division will be considered opposite operations. They undo what the other one does. So the reason why we would need to do that is because looking at our first example, if I have x plus 5 equal to 7, my goal is to get here. In other words, I need to get x by itself on one side of my equation. So I need to undo what's being done to x. So if 5 is being added to x, I need to subtract 5 to undo that addition of 5. Now also your equation is being split up into two sides, and that's left side and right side of your equal sign. Whatever you do to one side of your equal sign, you have to do to the other in order to keep your equivalency. So if I minus 5 on the left side of my equal sign, I need to also minus 5 on the right side of my equal sign. So the 5's cancel out on the left, leaving me with just x. 7 minus 5 is the 2 that we already knew was the solution for that equation. And that's the foundation of solving your equations. You're looking to get your variable by itself, and you want to undo what's being done to your variable so that you can do that. And you can always check your answer by plugging it back into your original equation. 2 plus 5 is equal to 7. And just to emphasize the other three basic operations, if we had y minus 10 equal to 20, I would add 10 to both sides of my equation, or the equal signs right here. 10's cancel out on the left, leaving me with y, and then on the right I have 30. Here we have 5a equal to 13. 5a is the same thing as 5 times a. So it means I would divide both sides by 5. A is equal to 13 over 5. So you don't have to convert that to a decimal. You are expected to write your fraction in simplest form, but you don't have to convert them to decimals or mixed numbers. So what I mean by that is if I had 4 over 6, I am expected to use that because the 4 is 2 times 2, 6 is 2 times 3. The 2's that they have in common will cancel and leave me with 2/3. So I am expected to do this type of process, but I do not have to take it to a mixed number or to a decimal, unless directions specifically say so, and most of them will not. Then the last one, here I got x divided by 9, so I'll multiply both sides by 9, and x is equal to 99. Any questions on anything so far? All right, so if I have 2x plus 1 equals 7, the most efficient move to make here is to, well, first recognize that there are more than one operations going on or being applied to the x. Before, all we had was y minus 10, 5 times a. Here we have 2 times x plus 1. So we have the 2 and the 1 that we have to move to the other side of our equation in order to get our x by itself. So the most efficient move is to move the, not the 2, the 1 first. And we can do that by subtracting 1. Now you could have divided by 2 first if you wanted, but if you do that, you need to divide, the whole thing by 2, which means you will divide each term by 2. And so you may introduce fractions into the equation where you don't necessarily have to. So it's best to subtract from by 1 first. So that'd be 2x equal to 6. Now divide by 2. 2's cancel. X is equal to 3. All right, let's look at another one. All right, so here we have 5x plus 9 equal to 23 minus 2x. So notice the difference between this one and the last one. One of the main differences, I should say, is that we have x in 2 different places. So here we should be trying to get x, all of our x terms on one side of the equation, and all of our terms without x to the other side. So we have 4 different terms here. It doesn't matter which one you move first or which side you take them to, as long as you do everything correctly, you'll still get the correct answer eventually. So what I will do is add 2x, because I want to move the whole 2x to the left side of my equation. So I'm going to add 2x to both sides. 2x and negative 2x cancels on the right. On the left, we have 7x plus 9 equal to 23. Now minus 9 from both sides. Seven x equal to 14. Divide by 7. X is equal to 2. All right. Any questions? All right, so here we have 8x minus 3 times the quantity of 4x minus 5 equal to negative 2x plus 6. So we want to combine all of our like terms. We need access to this x right here. We can't do that with those parentheses, so we do need to distribute. And we're not just distributing 3, we're distributing -3 into our parentheses. That's 8x minus 12x plus 15 equal to -2x plus 6. These two terms are on the same side of the equation, so I will go ahead and combine them. 8x minus 12x is -4x. And now we have the same scenario that we had last problem, in which our x terms are on two different sides of our equation. So we need to get all of our terms with x to one side, all of our terms without x to the other. Last time I took my terms to the left, so it doesn't matter which way you go. So I'll just show you can go to the right with it as well. So I started off by adding 4x to both sides. (15) equal to 2x. Remember, we're only going to add a like term, so x terms. (-2x plus 4x gives me a positive 2x, and that's a plus 6. And notice that they don't go over signed numbers, add, subtract, and multiply, and divide signed numbers. So if you need a reminder of that or help with that, make sure you shoot me an email. I know I've made videos on that in the past, so I can shoot you a link. Or if you wanted to, sit in an office hour Zoom or something like that, set up a Zoom hour, just let me know. But yeah, so I want to make sure you're straight with your signed numbers, add, subtract, and multiply, and divide the signed numbers. So from here, now we will subtract 6 from both sides. So 9 equal to 2x will give us a solution of x equal to 9 over 2. One side divided by 2. All right. Questions? Any questions before we look at another one? All right, so this next one, we have 3x over 4 minus 6 equal to x over 3 minus 1. So you have two choices here. Either you can work the problem with the fractions involved, or you can do what we call clearing out the fractions. So let's go ahead and look at that process. I can write. All right. All right, so first thing we want to do is find the LCD. So we want to find the smallest number that each denominator can divide into evenly. So the LCD for us in this problem will be 12. Because the 4 and the 3 can divide into the 12 evenly. Now, if by some chance you found a larger number, let's say you didn't see 12, you saw 24, as long as 4 and 3 can divide into them, you'll be okay. Just at the end, you will have to reduce. Not using the LCD will ensure that you will be reducing at the end. And that's not that big of a deal. You just have to make sure that 4 and 3, your denominators, 4 and 3 can divide into whatever you call in the LCD evenly. So the next step is to multiply each numerator by the LCD. And notice I said each numerator. We're not multiplying top and bottom by the LCD. We're multiplying each numerator by the LCD. So we're going to multiply across the equation. So each term needs to be affected by the LCD or you will change the value of the equation. So a lot of times people forget the terms that don't have the denominator. So make sure you multiply each term by the 12. Make sure I got my stuff right. 3x over 4 minus 6. Yep. All right, so now we can go ahead and simplify. The 4 divides into 12, leaves us with 3. 3 divides into 12, leaves us with 4. So what will be left is 3 times 3x, which is 9x, minus 12 times 6, which is 72, equal to 4 times x, minus 12. All right, so now we'll take our x terms to one side, terms without x to the other, and minus 4x. 5x minus 72 equal to negative 12. Add 72. 5x equal to 60. And now we can finish it off by dividing by 5. X is equal to 12. All right, let's do one more using that process. Let's see, where's my problem? All right, so we have 2x minus 3 over 3. That whole quantity is over 3. Plus 1 over 2 equal to 5 over 6. So going off our steps, we need to find our LCD first. So the smallest number that 3, 2, and 6 will divide into evenly will be 6. So now we take that 6 and multiply it to each numerator. All right, 3 goes into 6, leave us with 2. 2 goes into 6, leaves us with 3. 6 is canceled completely here, leaves us with 1. So before I do any distribution, just want to make sure we're okay with what is left. So that's 2 times the quantity of 2x plus minus 3 times 1 and 1 times 5. All right, distribute. That's 4x minus 6 plus 3 equal to 5. I can combine these like terms. Negative 6 and positive 3 will be a negative 3. Now I'll add 3 to both sides. 4x is equal to 8. Then finish it off by dividing by 4. X is equal to 2. All right, any questions? Any questions? Oh, see somebody raising their hand. So yeah, next time, yeah, I didn't, I'm sharing a screen. So if I don't see your hand, feel free to use your mic, even if you raise your hand, because when I'm sharing the screen, I'm not really seeing the Blackboard Collaborate. So I saw somebody raise their hand.
Yeah, it was me, Devon.
Okay. Hello. Hold on, did I lose you?
Hello.
Yeah, I'm here. Can you,
It,
what's
it
your
was me, Devon. Um, On that last equation, did you move the 3 instead of the 6?
Let me see. Are you talking about right here? Going to the
Yes, the
next
last
one?
one we just did.
Yeah. So first thing we did was we combined. We added these two together, and that's how we got that -3.
Okay, okay, I got it now.
Is it? Okay. All right. Cool. Cool.
Thank you.
Yeah. No problem.
Hi, I also had a
Hey.
question.
Uh-huh.
So, just in terms of fractions, if it goes into evenly for our final answer, do you want us to simplify it to the lowest term? And if it doesn't, do you want it to just leave
Yes.
it at a okay. Okay.
Yes. Uh-huh. So let's say if just to make sure everybody's with you. So if I come down and I have 8 divided by 4, you are expected to write, oh, that's a sloppy 2, but you are expected to write 2. If you came down and had 9 over 4, you're fine there.
Okay. Got it.
Yep.
Thank you.
Yep, no problem. And let's say if we had something like 14 over 4, you're expected to reduce that 2 times 7, 2 times 2. 2's cancel, and your answer would be 7 over 2. All right. Let's see. Let's see. One more thing out of this section. All right. So when you solve for specified variables, it's the only thing that's different from what we did, what we have done in previous examples, is that you're not solving to necessarily get a number. So in other words, x equal to 2 will not be your situation or your result. You will have x equal to an expression. So in other words, I have P equal to 2L plus 2W, and I want to solve for L. That means I want to get L by itself on one side of the equation, and then on that other side is going to be an expression because I don't have all like terms. All right, so I would treat these terms the same way I would treat numbers, and what I mean by that is if I had 5 equal to 2L plus 7, the first thing I would do is subtract 7 from both sides. So that's the same thing I would do over here with this expression. I have P equal to 2L plus 2W. I'm going to subtract 2W from both sides. So these letters represent numbers. They're just unknown numbers, but we can treat them the same way we would treat our numbers. So 2W minus 2W will cancel. On the left side, I cannot combine them. They are not like terms. So that's just P minus 2W. All right. And now I have P minus 2W equal to 2L. I will divide both sides by 2. And the 2's cancel on the right. So P minus 2W divided by 2 is equal to L. And that will be my expression. Now, before we look at this answer further, to make sure we know why this is okay, any questions on what I did? All right. So just to make sure, just in case anyone wanted to cancel out the 2's, and go further. Just want to make sure I emphasize what you can and cannot do. So you cannot cancel the 2's like that. So what I mean is that if you wanted to reduce further, as a matter of fact, let me just drop it down. If you wanted to reduce this further, you cannot cancel out the 2's and be left with P minus W. So that is incorrect. If I wanted to reduce this further, that 2 has to go into each term. And that's P over 2 minus 2W over 2. Now the 2's can cancel. And your final expression would be P over 2 minus W. So these two are equal. But that other one, when you just cancel out the 2's from jump, would not be correct.
I have another question.
Mm-hmm.
So, since these two are equal, do you care which final answer we have?
No, either one of them
Okay.
is fine. Yeah.
Okay.
And the only reason I emphasize that is because just this random scenario, if you guys had 4P minus 2W over 2, then this you would be expected to reduce because the 2 can divide evenly into that 4 and the 2. Now here the 2 couldn't go into P, so that's why it was okay to leave it like this. But here, if you would have had this scenario, you would have had to do 4P over 2 minus 2W over 2 and leave your final answer of 2P minus W. So that's why I emphasize that, is that if you have your denominator that can go into each term in the numerator, you are expected to reduce that. If not, then this is okay.
Thank you.
Yep, no problem. Questions before we do another one like this? Body all right? All right, let's see. Let's go. That's similar to what we just did. I'll just leave it. We'll do another one, but this one's similar to what we just did, so I didn't think about it till I wrote it down. We have 5A minus 3B equal to 7. We want to solve for A. First thing we'll do is add 3B. Five A is equal to 3B plus 7. Or if you had wrote 7 plus 3B, that's the same thing. So now we can divide by 5. A is equal to 3B plus 7 over 5. Say it again.
It's like I hear like something steaming.
You hear something steaming. Does
Yeah,
anybody else
like
hear that? Anybody else hear something other than me talking? Let me go back to. Okay. I don't know what that is. I don't. Is it? I mean, is it drowning me out? Because I don't hear anything other than me talking.
no, it's not
Say
Johnny.
it again. Okay.
I
What
said
I'll
it's
do is
not
I'll go back.
blocking you out.
Okay. Okay. What I'll do is I'll go back and listen to the recording, and see if I can figure out what that background feed is. Thanks for letting me know. All right. So the good thing is though, this is our last one for today, unless you guys want another one. We want to solve for R, capital R. Also, take note in this problem, we have a capital R and lowercase r, and they are different. So you can't combine capital R plus lowercase r and get 2R. Capital R and lowercase r are different. So they're different terms altogether. We are solving for a capital R. All right. So we have the capital R, but we need access to it. We need to get it out of the denominator. So we have to multiply both sides by R plus R. So what's going to happen is the whole quantity of R plus R will cancel out on the right. On the left, we'll have capital R plus lowercase r equal to E. So we needed access to that capital R. It was in our denominator. We needed to get it out of the denominator by multiplying both sides by that quantity that was in the denominator. Cancels out on the right, leaving us with just E. And on the left, we have I times R plus R. So we still don't have access to the R because it's in parentheses. So now what we need to do is to distribute I so we can get rid of the parentheses. So that's I times capital R plus I times lowercase r equal to E. We can now subtract I lowercase r. I lowercase r will cancel on the left. So we have I capital R equal to E minus I lowercase r. And so to finally get r by itself, we will divide both sides by the capital I, excuse me. I's cancel. That will be capital R equal to E minus I lowercase r over I. And that will be your final answer. All right. Questions? Any questions? All right. So that's 9.1. As with everything, try the stuff out. See if you get stuck. Every day is the opportunity for questions. Make sure you ask them, or if you don't want to wait till the weekend is over, you want to shoot me an email, you can do that as well. And I'll get to them as soon as I can and knock those out for you or help you out with whatever your situation is. Let me, all right. And like I said, I'll check that feedback or whistling and see if there's anything that I can do to correct that. But are there any questions? I know there's at least one person that needs to stay back and need to talk to her about class and class happenings. Are there any questions on anything we've done today or anything that's going to go on as we progress forward? Anybody? Okay, looks like we're good. I see silence or hear silence, right? I'm only going to do one section today. Like I mentioned before, some people are still just getting into class. You guys have all of chapter 7 to talk about. I mean, not to talk about, to go over, and you have your chapter 7 test. One day, either, let me see. What I can do is set aside Tuesday, unless you guys would rather have it on Thursday as a review day to just answer any questions that you guys have on anything like chapter 7, chapter 9, whatever. If we do that next week, would you guys rather have on Tuesday or Thursday? Squeaky wheel to get the oil.
Can you repeat
Thursday.
that for me again?
Yeah. So on Thursday, I guess everybody's done with the screen. I guess I can start the share. I'm still getting used to Blackboard Collaborate, trying to stop my share. Anyway, it doesn't matter. I don't need to stop the share. Anyway, so I was saying either Tuesday or Thursday, I can set it aside as a review day. So I won't go over anything new. But I'll give you guys a chance to answer or ask me whatever questions that you may have generated from out of chapter 7, especially when it comes to chapter 7, because you have your test posted. But whether it's chapter 7 or chapter 9 or anything that you may have questions on, you can ask me on that day, and I'll just do those questions, and I won't do anything new. So I see most people are saying Thursday, so it looks like Thursday will be it. So um, Thursday, and that gives you a whole week to see if you have any questions on anything. So make sure you guys take advantage of that. Thursday, I will not do anything new. It will be open class. I won't come. Well, probably, have some problems in the back pocket if I need to do something. No one has anything. Hopefully, you guys will have questions. The goal is for you guys to have questions, bring them to class, and we'll talk about them. If you're pulling them out of WebAssign, if you're pulling them out of book, whatever the case may be, I won't ask you where you got them from. I'll just attack those problems accordingly. So Thursday, we will set aside as a review day for you guys to ask whatever questions you want to ask on anything. So any questions, concerns, comments? Everybody good? Straight? All right. So if you are good, I'm good. I will see you guys on Tuesday. Have a great weekend and be safe.